Assalamualaikum and hi everyone. Okay, today we are going to continue our lesson on chapter 9, which is three-phase systems. Okay, the outlines for this topic are three-phase voltage generation, and then basic three-phase circuit connection, basic three-phase relationship, power in the balance system, measuring power in three-phase circuit, unbalanced loads, and also the power system loads. Okay, the first one, we will look into the three-phase voltage generation. Okay, three-phase systems are important for at least three reasons. First, nearly all electric power is generated and distributed in three-phase at the operating frequency of 60 Hz in US or 50 Hz in some other parts of the world. When one or two-phase inputs are required, they are taken from the three-phase system rather than generated independently. The second reason on why the three-phase systems are important is the instantaneous power in a three-phase system can be constant. This results in uniform power transmission and less vibration of the three-phase machine. The third one is, for the same amount of power, the three-phase system is more economical than the single-phase. The amount of wire required for a three-phase system is less than that required for an equivalent single-phase system. Three-phase voltage are often produced with a three-phase AC generator, or we call it as alternator. The generator basically consists of a rotating magnet called the rotor. Okay, so this is the rotating magnet surrounded by a stationary winding. We call it as a stator. Okay, the windings. Okay, the three separated windings or core with terminals are physically placed 120 degrees apart around the stator. A typical three-phase system consists of three voltage sources connected to loads by 3 or 4 wires or transmission line. A three-phase system is equivalent to 3 single-phase circuits. The voltage source can be either Y-connected or delta-connected. The three-phase AC voltage can be used to run the high-power electric load, for example, 5 horsepower or loads 400 volt. Okay, for the single-phase, it is used to run only a small domestic load. This is the animation on how the three-phase voltage are generated. As the rotor rotates, its magnetic field cuts the flux from the three coils and induces voltage in the coil. Because the coils are placed 120 apart, the induced voltage in the coil are equal in magnitude, but out of phase by 120 degrees. Since each coil can be regarded as a single-phase generator by itself, the three-phase generator can supply power to both single-phase and three-phase loads. These are the three-phase AC voltage generated by the AC generator. Okay, as mentioned before, as the rotor rotates, its magnetic field cuts the flux from the three coils and induce voltage in the coil. Okay, because the coils are placed 120 degrees apart, then the induced voltage in the coil are equal in magnitude, but out of phase by 120 degrees. Next, we move to basic three-phase circuit connection. Okay, there are two types of three-phase system, which is the first one is 3-wire system and the second one is 4-wire system. Okay, for each type of wire system, it has two types of connection, which is Y and delta connection. So for the first one, we look for the 3-wire system. Notice that we have 3 wires in the system. We have a red, yellow, and blue. Okay, same goes to delta connection. We have red, yellow, and blue. But for the 4-wire system, it has an additional wire which is for neutral. So we have red, yellow, neutral and blue. Also same for the delta connection. First, we look into the 4-wire system. 3 loads have common return wire which is called as neutral. If the load is balanced, the current in the neutral is equal to 0. Okay, the power system normally operates close to balance. Okay, this is the circuit diagram for 4-wire system. Okay, the return wire is called the neutral. Okay, so IN is represent the return current. Okay, so EN, EAN, EBN and ECN are called phase voltage. If the voltage sources have the same amplitude and frequency and are out of phase with each other by 120 degrees, the voltages are said to be balanced and the current is close to 0. The return current is close to 0 and the wire diameter of the neutral line can be smaller than the other 3 conductors. So this is the standard representation for 4-wire Y-to-Y system. Okay, it is called as a 4-wire Y-to-Y system because it has Y connected loads connected with the Y connected source. So EAN, EBN and ECN are represented as phase voltage. Okay, we have line currents, IA, line current for the phase 1, okay, IB, line current for the phase 2, IC, line current for the phase 3, and IN is the return current of the system. Okay, next we move to 3-wire system. Okay, this is the circuit diagram for 3-wire Y-to-Y system. It is called as Y-to-Y system because it has Y connected loads connected with the Y connected source. Okay, notice that we only have 3 wire which is A, B and C. So that's why it is called as 3-wire Y-to-Y system. We don't have the neutral line in between here. So the 3 Y-to-Y circuits may be used if the load can be guaranteed to remain balanced. Okay, in under balanced condition, the neutral conductor carries no current. So that's why we do not need the neutral line here. Okay, besides of Y connection, we also have delta connected generators. But for the practical reason, delta generators are seldom used in our system. As mentioned before, there are a few parameters that we need to consider in 3-phase system. The first one is line voltage. Okay, the line voltage, okay, you can see in this figure, okay, we have line voltage here. So the line voltage is actually the voltage between any 2 live conductor. Okay, so for this one, from blue to yellow. So this is the line voltage. Okay, and then we have the phase voltage. Okay, phase voltage. So the phase voltage actually is the voltage to neutral, or we can say that the voltage between any live conductor and the neutral point. Okay, in Y load, phases are from line to neutral, but in the delta load, phases are from line to line. So meaning that V phase are equal with the V line in delta load. Okay, and then we have a neutral point. Okay, it is usually at the supply end for the protection and the safety reason. And each live conductor is then at a definite potential to Earth.